Our next speaker is Sapan Sup Shah from Immuta. To switch things up a little bit, he told me to let everybody know, I asked all the speakers, is there something you want folks to know? Like skateboarding, and is looking forward to sleep this evening. So with that, I'll go ahead and turn it over to Sup.
Thank you. Thank you, guys. So before we get started, I first have to give credit for the name of this talk to a colleague named Jim Klukar. He's not here right now, but he named the talk, or else it was just going to be called Reactive Programming in Accumulo. How many people, just a quick show of hands, how many people saw Joe's talk this morning? So a lot of similar concepts are going to happen here, just to give you a heads up. If you guys go on Twitter or anything like that, let's try getting a hashtag going, hashtag reactive programming, because that's probably the topic from this summit. So it's one of the fun ones. So I'm going to take a little bit of a different approach to it, which is the way that programming works nowadays is you have two paradigms, right? We came from a world of a pull paradigm, where we constantly polled, things were good, and that worked really well because that's how HTTP works, right? You're on a server, you use the server, you make a request, you poll something, you get it down. That's great, and that worked really, really well for a bunch of years. However, it doesn't quite scale as well as we'd hoped, and as data's gotten bigger, it doesn't quite work, because as you have multiple clients polling all the time, you're going to get lag. You rely a lot on the database to do all sorts of things, to use caching, and then you rely on caching and your caching invalidation and stuff like that, which is fine, and it's worked really well for a while, but it's introduced a completely brand new set of problems. So in this talk, we're going to talk about a little bit of a push approach, which is using Accumulo's Write-Ahead Log and actually making it observable. How many people are familiar with the observer pattern? So it's very much like that, which is use the observer pattern, view the write-ahead log, and then actually act on things. So what is write-ahead logging? So Wikipedia defines it as a family of techniques for providing, atomic and durability and ACID properties in a database. Okay, so what does that really mean? It means that updates to the database are done in place. This has the advantage because it reduces to modify indexes, and it makes sure that you don't have to store in a whole bunch of different places. So what is the primary use case, or why write-ahead log came about? It's because write-ahead log was primarily used for disaster recovery. And as anyone knows, in big data, there's the CAP theorem, but there's also disaster recovery, which is what that really stands for. And write-ahead logging is a technique which all modifications to the database are written to a log before they're actually applied. So usually both redo and undo information is stored in the write-ahead log. And this guarantees that all modification to the data can actually be played and replayed. So let's talk a little bit about how Accumulo does its write-ahead logging, which is actually kind of slick, and it very much models the big table way of write-ahead logging. So write-ahead logs in Accumulo are stored based on the tablet server. This actually causes a pain, which I'll explain a little bit later. And write-ahead logs are stored in HDFS now as of Accumulo 1.5, which makes life significantly easier, especially in the case of disaster recovery. In this case, it's generally under /Accumulo/WAL and the tablet server import. They're written at HDFS so that it's available to all tablet servers. Before, it was actually local and it was kind of a pain. Now, because it's in HDFS, it's available everywhere. And Accumulo write-ahead logs, it's just a file, which is a series of key value pairs of serialized objects. So it's nothing really, really special. There's not a huge format, that you have to worry about. So let's talk a little bit about how the flow goes. So we got our user, he wants to do a write, goes to the tablet server. Then from the tablet server, it writes it to the write-ahead log, the mutation. Then that mutation goes to a mem table, which will eventually get minor compacted down into the ISAM file. And then that compaction will be noted in the write-ahead log. So there's actually a bunch of places where we're writing to the write-ahead log to gather information. So let's talk a little bit about how the master uses the write-ahead log. So according to the Accumulo manual And in the code, you can actually see this. The master will coordinate startup, shutdown, and recovery. The recovery being the key part, using the write-ahead log in case a tablet server fails. What that means is that the master will take care of, if a tablet server fails, it'll take the failed tablets and it'll use the write-ahead log to copy entries that were in the mem table over to different tablet servers so that you can actually recover. So that's kind of cool. But there's other stuff that we need to find out in order to use the write-ahead log. And the major part of that is what information is stored and how can I get to it. The major bit that's stored in the metadata table is something that looks like this. It's a very long entry. But from here, we'll dissect the entry. And the 3 over there, in this case, is for the actual ID of the table. Then that log 127.0.1, that's actually the name of your log file. So you go to /accumulo/WAL, then the 127.0.0.1 plus 997, and then that gigantic hash. And that actually gets you your log, your log file. Now what's really interesting is that last pipe 6, that actually comes in really, really handy, because that pipe 6 tells me that that particular tablet that we're writing to that write-ahead log, it's encoded with a value of 6 inside the write-ahead log. And this becomes really important because when you're looking for tablets, you need to know how it's encoded in the write-ahead log. So the log files are, as I explained earlier, are a pair of key and value pairs. The values aren't as interesting as the keys. With the keys, we can gather a ton of information. Here's where the source is located for the key in case you want to actually look at it. It consists of a log event, which is either, currently that's an enumeration with open, defined tablet, mutation, many mutations, a compaction start, and a compaction finish. Kind of like the flow that we were talking about over here, right? Here's the mutation, many mutations, in the 1, and then the compaction for 3. So then it also has the tablet ID. Remember that 6 that we talked about? In that key is the tablet ID that it corresponds to, which in this case would be that 6. And then it's going to have a various set of information depending on what the particular event is. It'll have a T server session in the case of open, file names for the case of compaction of what file it's going to go to. And the one that I really care about is sequence, because that's what comes with the mutations and many mutations. And generally when you're actually observing this write-ahead log, the major thing that I want is mutations out of the write-ahead log. And then it has the key extent tablet for the defined tablet. The defined tablet event is actually very, very important, and I'll explain why in a little bit. The LogFileValue. So basically, just generally used when you're dealing with the mutation and many mutation events. The value itself literally consists of a number of encoded mutation objects, and it serializes them to the write-ahead log. So it's literally a mutation object which you can then read into Thrift or read into JSON if you wanted to. So reactive programming. So Joe talked about reactive programming earlier. I kind of have a little bit similar approach, but for me, reactive programming is that everything is a stream, right? We live in a streaming data world, and so the dog has it right? Everything's a stream. An example of reactive programming are click streams or event buses. Those are really good reactive programming models. So let's talk a little bit about reactive programming and the Reactive Manifesto. It's a great site if you get a chance to read it. It's Reactive Manifesto. So a reactive system should be the following 4 things, right? It should be responsive, so that you have no downtime, no lag time. It should be resilient, such that if any piece of it fails, you're good to go. Going back to the dog, it should be message driven, so everything's a stream of messages, and it should be elastic, right? It should be able to scale up and down as you need to, right? A very good example of reactive programming right now is Apache Storm, but the other really cool one actually is Apache Spark, which is the new one that everybody likes, so highly recommend that one. Give that a shot. So why should I care about reactive programming? Modern applications, as they exist now, it's becoming way more collaborative, right? If I'm doing something, I want to be able to share it with my colleagues so that they can actually look at it too, right? Even look at, programming, right? I'd say about maybe 20 years ago, the idea of pair programming was crazy. Nowadays, we have collaborative cloud editors where you can all work together on one file, and sometimes that doesn't really end well. Okay, most of the time it doesn't end well, but you can actually do it, right? You have things where people are constantly wanting to get together and they want to talk and they want to work together. So applications are not just one user, it's one user talking to a community. The polling model, like I said earlier, it has problems scaling to this, as users would put constant load on the database due to low polling intervals. And that's only to keep up with the database, right? If I have a database, let's say Accumulo, and I have, 100 users, now I have 100 users scanning that table over and over again. So now I'm creating a caching framework so I don't have to hit Accumulo that much, but now my users are hitting my cache, and it goes into this long, crazy caching value mess. And most modern systems and databases are moving to a push infrastructure to ease the stress on the database. So if you look out at Elasticsearch, for instance, they have streams. Those are rivers, sorry. Those are very, very cool. HBase actually now has a version of polling, which is kind of neat. MySQL and all those guys, they only use the write-ahead log to actually do replicas, but someone has actually proposed using the write-ahead log to actually do queries in-memory real-time queries. So it's kind of slick. So I talked about two things. Why should we even care? Because the write-ahead log plus reactive programming means that we can have fun using Accumulo. We can use the write-ahead log to monitor for the mutations, and we can use the write-ahead log to monitor for deletions. We can basically get all the modifications and things like that. Well, one of the major uses in Accumulo 1.7 for the write-ahead log was actually to do replication. So the replication system actually works via monitoring the write-ahead log and writing that all out. What I like to use it for is the fact that the major paradigm that I have is I use Accumulo as my backing data store. So it is a great file store, it is a great document store and things like that, but I have a bunch of other indexes. So I have things like an Elasticsearch, for free text, I may have PostGIS for geospatial. The problem that I ran into constantly was that I would have to insert into Accumulo, then take that same document, and all within the same code, insert into the individual databases. Now, because I'm monitoring the write-ahead log, I can actually just look at the write-ahead log, and then that pushes it to my various things, and I only have to subscribe to a particular table. So I don't have to ever update my code. I can release a brand new piece of code that scales independently. So it makes my life a lot easier. You can also use it to trigger website updates, which is really nice too. All right, so you say, Soup, that's cool. How do we do it? So we want to write a simple program to create an event stream for tables. Basically, 4 things. Step 1, monitor the write-ahead log for updates using the multi-reader class, or you use the DFS streams class. No big deal. Step 2 is a little bit trickier. You have to correlate the tablet IDs to a particular table. Step 3, you push the mutations to the user. And step 4, let's profit. Sounds easy enough, right? Especially step 4. So let's talk a little bit about step 2. So the way that you correlate tablet IDs to a particular table is kind of tricky, right? Because you need to know, there's really, not that I know of, Aaron might know better if there's one magical call that says, get me all tablets for a particular table name. But there isn't one that I know of right off the top of my head. So the best way to do it is you can actually grab, remember earlier when we were looking at this, that number 3, there is a call to say, take my table name and translate it into the ID that Accumulo uses. Then based off that ID, if you look back at the way that this worked, one of the things that I didn't mention was when that defined tablet comes in, it will write that definition of a tablet. So before you can ever write a mutation to said tablet, it must first be defined in the write-ahead log. So the way that you do it is you simply go through, you are monitoring all these write-ahead logs anyway, so you take your tablet name, you have your table ID, the particular write-ahead log entry for the defined tablet also contains this key extent. In that key extent lies the ID of the table that it's a key extent of, which roughly correlates back to a tablet. You then use that to grab the particular tablet ID that you're interested in. So anytime you want to grab tablet IDs for a particular table, this is the only way that I could come up, or honestly looking through the code could find a way of doing. It's actually fairly clean. Like, I thought at first it would be really, really horrible, but it's actually not that bad. So, cool, we did step 2. Let's move on to step 3 and step 4, but wait a minute, Accumulo is about security. So, I talked about this really great system about monitoring the write-ahead logs and things like that. However, one of the more interesting bits is I've also now just done completely away with visibility filtering. And that's probably not a good thing. So before you implement any one of these systems, please make sure to add some sort of security verification. Currently that is on you, the user. The logs are encrypted on disk, but as you're writing something to read said logs, which the code isn't very hard to find, you can get away with not having to actually filter the particular mutations. The easiest method I've found of doing this is when the users register for notifications. You gather their security credentials and then you verify it on each mutation before you send it out. So Accumulo has no built-in mechanism at this level to guarantee security visibility, so it is left up to the application, right? The visibility iterator takes care of verifying that you are actually allowed to see this. So please, if you are going to go down this route, please implement security. Honestly, it shouldn't be on the database to enforce it at this level because it's not a standard paradigm. So please don't go out there and everybody start saying soup broke Accumulo. So now let's get back a little bit to Lambda architectures, which are very much like reactive programming, but Nathan Marge decided that he didn't like the words reactive programming and came up with his own. And he's, really smart, so we all listen. So Lambda architectures are basically like reactive programming in that it has, a couple different layers. You have a batch layer, which does your map reduce and things like that. You have a speed layer, which is for your real-time data and your reactive programming. You have a serving layer, which does exactly what it says. It serves up your things for queries. So this Lambda architecture honestly describes the vast majority of Silicon Valley companies out there, right? If you look at Facebook or Google, they need to use batch to come up with models let's take Google News. They use the batch layer to run map reduces to come up with models against news data to figure out, let's say, who's quoting someone, and they figure out someone's quoting style. Then they use that model so that when news articles are coming in, you can use it in the speed layer to quickly extract out the quotes or something for a particular user. And then you can serve that up really quickly. So it's actually, I laugh and I joke about it, but it's actually the vast majority of the common big data use case out there. So Lambda processing is a data processing architecture designed to handle massive quantities of data by taking advantage of both batch and streaming processing methods. Reactive programming is best used with the speed layer of Lambda architectures. So perhaps the greatest and newest Lambda architecture out there is AWS Lambda. So Amazon built their own version of Lambda and they built it to run on top of their ecosystem, which is great. So what happens is, for those of you who haven't played with AWS Lambda, highly recommend it. So what happens is, let's take DynamoDB. You get a DynamoDB event that is pushed to AWS Lambda. AWS Lambda gathers, the particular event. It extracts out the metadata, figures out basically what things are registered to hear that event, and based off of that, it spawns up a bunch of your code using Amazon stuff in their own little isolated container and takes care of scaling it for you, and then pushes your stuff over to the Node.js, or in their case, they only do Node.js right now, to that Node.js code, then you act on that Node.js code. This is actually really, really powerful when you think about it, because now, let's say you're on S3 and you upload a photo to a bunch of, you upload a photo to S3, which is a very common use case. Now I can have a piece of code that sits there and says, go notify my friends. Or I upload a photo and I recognize people in it and I want to send it to them so that they get a copy right away. So, 5 months later, they're not saying, hey, can you send me that photo? So you can do that and do some really, really cool and very, very powerful things with it. So I highly recommend it. The one problem, though, is that doesn't quite work in our world where we don't do everything on AWS all the time. So this is a plug for my company's product now. The name of the product is called Stargate. It does everything the AWS does, and it's an AWS Lambda clone, except I do it on different pieces of architecture, so you can do it via Accumulo, HDFS, or Storm. You send an event to the Stargate, and I use Docker containers, which I spin up and down automatically. So earlier Joe was talking about how you Mesos all the things. I sort of agree with that, which is I want you to Docker, containerize, microkernel, there's a bunch of terms for it now, all the things. And then you can scale that individually. And so now, as you get these events in, kind of like an Accumulo event using the Observable Write-Ahead Log, you're actually able to spin up and down Docker containers to handle dealing with your particular event. So basically, so you say, well, that's kind of cool. What does that do? So basically, users upload Docker containers, which are used to subscribe to events. Each container has a REST server inside of it. So we make you implement a REST server, and we make you add the /events endpoint, which takes a post request, which is where my JSON is posted to. Security is handled by Stargate++, which I'll talk about a little bit later. And then scaling will also be handled based on the events. So the idea is that you can write in whatever language you want. I don't care. Just implement something in REST, and I will send you the event via REST. I also don't care about what types of events you're taking in. So you can take in a MySQL event, you can take in whatever, and you're completely pluggable to write these events because the JSON structure just requires you sending in an event type and an event key. If you send in those two things, I'm capable of routing to where it needs to go. So it's very, very minimal. It's very, very easy. We did Docker containers because microkernel images, quite frankly, are a pain in the butt to actually get running if it's not your own system. The Docker image file is significantly easier to dynamically scale and whatnot. So, any questions? So I think that this actually works in parallel with it. So Joe and I were actually talking about this. So I think what you can do is, and the way honestly that Stargate works a little bit is you actually take, well, hold on. First, the question is, do you recommend this over a Kafka queue? So I think it works, I think it works in tandem. So I think that the Kafka queue is great. I think what you do is you take the mutations that you get from Accumulo and you actually push them to Kafka, and then you have your people subscribe to the Kafka queue. So it actually works together. And I think it works really, really slick and really, really easy. So Stargate is basically, it's a REST server. So the question is how does Stargate compare to Kafka? Stargate uses Kafka as its message queue internally. So you need kind of a message queue to do this type of stuff. It's plug and play, so you can actually theoretically use any message queue you wanted to. Yeah, no, that's correct. You could actually use the SQS and the messaging paradigm to do that. So the little bit here at the end is I actually broke this up, which is Stargate is the push-pull paradigm part. The actual Accumulo code I wrote elsewhere so that you can see how to actually monitor the write-ahead log, because honestly, one of the hardest parts that I found searching through the code was coming up with a consistent way of actually viewing the write-ahead log. The same piece of code is like everywhere. So this is just basically a very small framework, and inside of it you have handlers, and you write your own handler for how you handle the various events that are coming in. So it becomes a lot simpler. I think I'll probably talk to some of the Accumulo committers about maybe pushing this back in there so that replication and things like the log file reader and stuff like that all kind of follow the same path. But yeah, you could do it via AWS. The problem is some people don't actually run on AWS. So if you're running on your own internal servers, it'd be nice to have the same functionality. I think that's, so the question is, do you see the Accumulo users actually building a service like this? Yeah, I mean, I I don't see, I think that it's doable. I'm not sure that it falls quite under the realm of Accumulo itself. I think it's more of an open source, I think that the push-pull notification and the write-ahead or the event logging is a little bit different. I could see possibly fitting the observable part back into Accumulo eventually. And I'd probably talk to some of the committers about that, about how we'd like to probably put it in and, actually do step 2.5 and verify the security, because I'm sure that they would probably kill me if we didn't do that. Yeah. So I think that we would actually have to figure out a good way of doing that, but I would see it being more than doable. I think this is the next generation of the iterator framework, right? The iterator framework already allows for something like this. They just do it at query time. This now lets you do it at ingest time. So it's something a little bit different. Thank you. We did not technically trademark it, but yeah, Stargate, the idea is that things go in and they come out the other end. So a couple of these things. So the thing I posted online, the first one, Stargate, I've included what's called Stargate Lite, and that's open sourced right now. It's written in Python because I felt like writing in Python last night. So Stargate Lite will show you the paradigm idea. It'll show you how to dynamically spin up the containers. It has a basic REST service, so you do everything via curl, but it's got a basic REST service that sits there, lets you register particular events, spin up, and it just spins up Docker containers and spins down. So it's just a light version, kind of doing the Google type approach, which is I'll show you how to do the idea, but I'm not going to give away my implementation just yet. The Accumulo Observable Write-Ahead Log, that's exactly what it sounds like. It's a very simple Java framework to actually set up something to sit there and look at the various write-ahead logs. I took basically the Accumulo Write-Ahead Log code, plopped it in a framework, and added the ability to tail files to it, since nobody actually does that. So this actually tails the files. The Lambda Architecture, highly recommend reading this site, lambdaarchitecture.net. It was written by someone who follows Nathan Martz very, very well, and any Lambda architecture type stuff that's coming out, it's generally announced there first, and if it isn't announced there, people are ridiculed shamelessly on the web. The Reactive Manifesto I talked about earlier. I know anytime you use the word manifesto at one of these conferences, someone's going to come talk to me afterwards. Highly recommend that one too. It's actually a very good read on reactive programming and how the vast majority of these systems are designed completely under the hood. And then honestly, this is kind of random, but this gist actually does probably the best job of explaining the various concepts in reactive programming better than any tutorial or website I've seen. And it's just some random guy's notes, but they're really, really well done. So highly recommend reading that gist. Any more questions? So says the Riddler. All right, thank you.